Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from autumn 2022. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 6 to 9, which account for 19 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 6. Small oranges cost X pence each. Large oranges cost twice as much as small oranges. Write an expression in terms of X for the total cost of 4 small oranges and 6 large oranges. Give your answer in its simplest form. Okay, so small ones cost X. That's handy. Large ones cost twice as much as small ones. So small ones cost X. Large ones must cost 2X. Okay, so now we want an expression in terms of X for the total cost of 4 small oranges. So 4 lots of X. So 4 times X and so plus 6 large oranges. So we want to do 6 times 2x because each large orange is worth 2x. Now notice I put brackets there because we're doing 6 multiplied by 2x. Okay, guys. So we have 4x and then 6 multiplied by 2x is 12x. And we want it in our simplest form. So we've got 4x add 12x. These are like terms. They've both got exactly the same letter and exactly the same power, so we can add them together. We have 4 of them and 12 of them, so we have 16 of them in total. Okay, part B. Lemons cost Y pounds for a bag of 4. Write an expression in terms of Y, so we're working with Y this time, for the cost in pence of 1 lemon. Okay, so they want the cost in pence, but they've given us Y in pounds. Okay, so what we need to realise is £1 is 100 pence. So instead of Y, I'm going to use 100Y. Okay, it'll be easier to use, so bear with me on that. And then that is for a bag of 4. Okay, well, we don't want a bag of 4, we want 1. Okay, we want the price of 1 lemon. So we're going to divide by 4. So we want to get to 1. So 4 divided by 4 is 1. So 100y divided by 4 must give us the price of 1 lemon. 100 divided by 4 is 25. So 25y is an expression for the cost of 1 lemon. Now I know I've written equal signs here, guys, but it's purely to lead into the simplifying aspect. All right, so this is our final simplified expression. It's not an equation. Question 7. Thomas owns a takeaway food shop. Here's part of the menu. So this is part A. So 1 chicken piece. So 1 costs £2. 2 costs £3.20 and 3 costs £4.20. So Jean orders 4 chicken pieces and Thomas charges them £6.40. For this first part, they want us to show how Thomas has worked out the cost of Jean's 4 chicken pieces. So we've got to compare the costs here with the price that Jean's paid so we can figure out how Thomas has worked this out. Okay, so there's 4 chicken pieces. So if he'd have charged £2 per chicken piece, that would have been 4 times 2, which would have been £8. He hasn't charged £8, so he's not used it as single chicken prices. We're going to look at the 3 chicken pieces. That's £4.20. So the difference between £4.20 and £6.40 is £2.20. Nothing costs £2.20. So he must have gone with the 2 chicken pieces price, which makes sense because 2 is a factor of 4. 4 is a multiple of 2. So what he's done is he's worked out 2 times £3.20 to get the £6.40 for Jean's cost. Okay. Jean says You've charged me 20 pence too much. Show how Jean might be correct. Well, the other option we've got here is that there's another way of making 4. So 4 pieces, we did 2 times 2, but what if we did 3 plus 1? Okay, so 3 chicken pieces is £4.20. 1 chicken piece is £2. And when we add those together, that gets £6.20, which is 20p less, isn't it? It's 20p less than what she's being charged. So that's how Jean may be correct. Okay, part B. Thomas orders some food trays. The table shows his options. So he can buy these different number of trays. So for 25 trays, it's £5. For 50 trays, it's £9. 100 trays, it's £17, and so on. He spends exactly £83 on trays, and he orders as many as he possibly can. So we have to figure out how many trays he orders. So he spent £83 on trays. So he can't have ordered 1,000 because he hasn't spent £99. Okay. So he's definitely not ordered 1,000, but he could have used a combination of any of the others. Okay, so we're going to figure it out here. So I'm going to start by combining values to make 83 trays. Now, if he wants to order as many trays as possible, I'm going to see how many of the larger number of trays we can get first. So he can get 250 trays for £33. Okay, so let's do 83 take away 33. So that leaves him with £50. So he could do that again. He's got enough left to get 250 trays again. So if we do the £50 take away the 33, remember 0 take away 3 we can't do and get a positive answer. So we're going to borrow. 10 take away 3 is 7. 4 take away 3 is 1. So he's got £17 left. Remember, this is the money that he's spent, £17. So he's done 250 trays, 250 trays. So he can get 100 trays as well. So 100 trays would cost the whole of that £17 that he's got left. Okay. So we want to know how many trays he ordered. So we're interested in this total now. 0 plus 0 plus 0. 5 plus 5 is 10, plus 0 remains at 10. Carry the 1. 2 plus 2 is 4, 5, 6. So he orders 600 trays in total. Question 8a. Find 2 whole numbers that have a difference of 20 and when one is divided by the other, the answer is -9. So we're looking for 2 whole numbers, a difference of 20. One, when divided by the other, gives us an answer of -9. So the important thing here is if we get an answer of -9 when we divide, that means that we must have a positive number and a negative number, because that's the only way we're going to get a negative answer when we divide. So we're looking for a positive and a negative number. So I'm going to start by thinking about numbers that would divide to give me 9. So we're going to work with our 9 times tables here. So 1 times 9 is equal to 9. So that tells me that 9 divided by 1 is equal to 9. 2 times 9 is equal to 18. So that tells me that 18 divided by 2 is equal to 9. 3 times 9 is 27. So that tells me that 27 divided by 3 is equal to 9. So let's just start with these ones for now. We're aiming for -9, but I'm working with my 9 times tables. And remember that we need 1 positive and 1 negative number. So these are potentially our pairs that we're looking at the minute. But we need one of them to be negative to give us an answer of -9. So it could be that we do -9 divided by 1 to get -9, or we could do +9 divided by -1. Same here, we could do -18 divided by 2, or we could do +18 divided by -2. It's just one of them that needs to be negative. And then the same here, we could do -27 divided by +3, or we could do +27 divided by -3. All of those are going to get us that answer of -9. But we want the numbers to have a difference of 20. So let's have a look at this. And we're going to think about a number line, okay, guys? So when we work with a number line, if I draw one really quickly, it's going to be a rubbish number line, so just bear with me. So if we've got 0, 1, 2, 3, 4, and then we have the negative numbers. Like that, okay? So if we're looking at -9 and 1, well, -9 is going to be down here. And to get from -9 to 0 is 9 places, and then to get to +1 is another place, which is 10. So -9 and +1 have a difference of 10. We're looking for a difference of 20. So let's go with -18. So if we've got -18 here, to go from -18 to 0 is 18 places. But then we're going to +2, which is another 2 places. Well, 18 plus 2 is 20. So that's our difference of 20. So we're going to use these pairings, and it doesn't matter which pair I choose, whether I go for -18 and +2 or whether I go for +18 and -2, we're still going to get the right answer. So let's just write this first one down. Let's go -18 and +2. Okay, part B, find 3 whole numbers. So again, we're working with whole numbers that multiply to give 24 and add to give a total of -5. So that adding for a total of -5 is what's important here, because that tells us that we're going to need negative numbers as well as positive, because that's the only way we're going to get a difference of 5, of -5. If we add all positive numbers, we're not going to get -5 as an answer, are we? So we're going to need a mix of positive and negative numbers again, but we're looking for 3 of them this time. So I'm just going to start by finding numbers that multiply to give me 24, because that's the first criteria. So 24 is an even number, so I can do 2 times something. Well, it's 2 times 12 that gives me 24, but currently that's only 2 numbers. So what I'm going to do is I'm going to split 12 into 2 numbers as well. So I've got 2 times, and then I want 2 numbers that will multiply to give me 12. Okay, so I'm going to just go with 3 and 4. So 2 times 3 times 4. 2 times 12 is 24. 2 times 3 times 4 is also 24. Now we have 3 numbers. So let's get rid of these so we don't confuse ourselves. But the problem here is we've got 3 numbers, but we need a mixture of positive and negative so that when we add them, we get an answer of -5. So let's start by just making one of them negative and see what happens. Okay. So 2 times 3 times -4. We've got a positive times a positive, which gives us a positive, times a negative, which gives us a negative, and we want a positive answer, so it's got to be 2 of them that are negative. Okay, so let's do 2 times -3 times -4. Well, 2 times -3 is -6, times -4 becomes positive 24. Okay, so this works, but we need to add for a total of -5. So if we're adding them, we have 2 plus -3 plus -4. Remember, those signs stay with those numbers. So 2 plus -3 becomes 2 minus 3, and then plus minus here becomes a minus again. So 2 subtract 3 is -1, and then -1 subtract 4 is -5. So we're going to go with these 3 numbers here. So we're going to go with +2, -3, and -4. It's really important with these kind of questions that you're systematic, guys, and you just try things out. But remember those number properties. Okay, remember whether we're going to need positive or negative numbers. Question 9. Alan builds a model of a steam train. So first of all, if we're talking about models, I'm expecting to see a scale somewhere in this question, guys. Here we go. The scale he uses is 1 centimetre represents 75 centimetre. So this is 1 centimetre on the model represents 75 centimetres on the real train. So a real life full size train. Part A. The width of a wheel on Alan's model is 3 centimetres. What's the width of a wheel on the steam train? Okay, so we're working with this scale here, and I'm going to use a proportion table. We know that I like those if you've watched any of my previous videos. So we're dealing with the model and we're dealing with the actual train here, guys. Okay, so on the model, 1 centimetre is the same as 75 centimetres on the real train. The width of the wheel on Alan's model is 3 centimetres. So I'm going to write that in my model column, 3 centimetres. And what we do when we're working with a proportion table is we scale up or we scale down. So we multiply or we divide. So to get from the 1 centimetre in my scale to 3 centimetres, I've scaled up, so I've multiplied by 3. So if I do the same on the other side of my proportion table, that will tell me what 3 centimetres is on the real steam train in actual real life train size. So we're going to do 75 times 3. So I'm going to do 70 times 3 and 5 times 3. So I've split 75 up into 70 and 5. Well, 7 times 3 is 21. So 70 times 3 must be 10 times bigger. So that's 210. 5 times 3 is 15. And when we add those together, we get 5, 2, 2. So it's 225 centimetres on the actual steam train. Now, there is no answer line on Eduqas papers, but you just need to make sure that your answer is nice and clear, or that they can see it if there's lots of working out. So let's just highlight that there for them. Part B, the length of a whistle on the steam train is 375 millimetres. So this is on the actual train, so the full size train, not the model. What is the length of the whistle on Alan's model train? Give your answer in centimetres. So the first thing we need to realise here is that we're given a length on the actual train in millimetres, but our scale is in centimetres and we want our answer in centimetres. So what will work really well here is if we convert millimetres into centimetres. So there are 10 millimetres in every centimetre. Okay, so 10 millimetres is 1 centimetre. So to go from millimetres to centimetres, we need to divide by 10. So 375 millimetres divided by 10 is 37.5 centimetres. Remember, when we're dividing by powers of 10, the numbers shift in place value 1 place to the right for dividing by 10. So that's 37.5 centimetres. Now we can work with our scale again, our little proportion table. So we've got our model and we've got our train. So we've got 1 centimetre is 75 centimetres in real life. We've got that from our scale. Now we know that in real life, the length of the whistle on the actual train is 37.5 centimetres. So we're going to put that in the actual train column this time. So what you can see has happened here, we've scaled down because 37.5 is less than 75. So we've scaled down, so we must have divided. So we're going to have to divide this side. The tricky part is figuring out what we divided by. Now I know that 37.5 is half of 75. Okay, so I know I need to divide by 2 on both sides. However, if you didn't know that, you could do 37.5 plus 37.5 and add them together. So that's 5 plus 5, that's 10, carry the 1, 14, 15. And then you're like, oh, it adds to 75, so it's 2 of them. You could keep going until you see how many of them fit in. Okay, so that's just a top tip for you there. So we're dividing by 2. So we're going to divide by 2 to find out the length of the whistle on the model, and we're working in centimetres here, which is good. 1 divided by 2, I'm going to write as 1 divided by 2, which is a half. So it's half a centimetre, okay? So the length of the whistle on Alan's model train is half a centimetre, and I'm going to make that nice and clear as my answer. Excuse me. Part C. Alan's model train has 6 wheels. Alan's friend Mandy says the steam train has 6 times 75, so that's 450 wheels. Explain why Mandy's not correct. So Mandy's not correct because this scale is in centimetres. It works with lengths only, guys, okay? Doesn't work with anything else. There's no way we'll have 450 wheels on a steam train in real life when the model only has 6 wheels. On the model when the train only has 6 wheels. Does that make sense? So we're going to say that, ignore my dogs in the background, I'm so sorry. The scale works for lengths only. The train will still have, sorry, my dogs are going mental, 6 wheels. So the number of wheels on that train, whether it's the real life train or the model, are not going to change because that scale only deals with modelling the lengths to give us a scale model of our train.